right, let's do a quick recap of the lesson. Yeah, if you can see that screen over there, let's see if you can calculate the perimeter and the area of the sector. Okay, go ahead, jump into this. Type your answers in when you're done. Press pause, give it a go. When you're done, press play. If you haven't started yet, these are some formulas you can use. The area of a circle is given by pi r squared, and the perimeter of the circle, which is the circumference, is given by 2 pi r. Okay, try those two formulas. And what you want to do is find the area in the perimeter. This is a fraction of a circle. All right, give it a go. 2 more minutes. Try it. Just try it. I'm going to go through it anyway, okay? All right, give it a go. Press pause, try it. Press play when you're done. All right, let's go through it quickly. So basically what we have for here is, firstly, you can see this is a fraction of 100. Now we know that an entire circle will be 360 degrees. So we take 100 degrees out of 360 degrees, and we multiply that by pi r squared, which is the area of a circle. This is going to get me the area. The radius is 4, so that becomes 4 squared. Grab a calculator, put it in the calculator, and you got your area. So 100 divided by 360, a fraction of a circle. So the circle is pi r squared, the entire circle is pi r squared. So shift pi times 4 squared, which comes to 13.96 centimeters squared. All right, so 100, and that's going to be this area over here. All right, so as you can see, who can see what I should have done for this question? Can you see that that number is incorrect? Because I just calculated that area. What I should have done is use this area. Now, do we know what this degrees is from there till there? Not 360. 360 is the entire thing. That's going to be 260 degrees. So this number here is supposed to be 260 degrees. And that is the correct formula that you're supposed to use. So some of you shooting out the wrong answers there. Have a look at that. And that answer was supposed to be 36.3 centimeters squared. And that's the answer for area. Perimeter is calculated by simply adding all the sides, right? But we have this side that goes all the way around. We have this side that goes all the way around like this. That is a fraction. 260 out of 360 multiplied by the circumference, 2 times pi times radius, which is 4. So that's going to be 2 pi r, right? 2 pi r. No squaring involved in this. All right, so 2 pi r, and that comes to 2 times pi times 4, because my radius is still 4. And I can see that comes to 18.51, so that will be, that part there would be 15 meters, centimeters. Okay, so that's 18.15 centimeters. Then we add 4, and we add this one as well, 4, and we got the perimeter. 4 plus 18.15 plus 4. So we plus 4 plus 8 comes to 26.15 centimeters perimeter of the entire shape. Okay. Shall we try another one? Do you think you can do it now? Maybe take a quick screenshot and I'll give you some new values. Tell me when you're ready. All right, here we go. I am going to change the numbers around a little bit, keep the sector the same. You can calculate the following area parameter. Okay, let's change this to okay, here we go. I'm just gonna make this 8 centimeters now, and I'm gonna make this angle. Watch this carefully. This angle here is now 120 degrees. Get me an area, get me a perimeter. You got 2 minutes, and then I'll go through it in 2 minutes only. All right, give it a go. Press pause, try it. Press play when you're done. All right, let's go through this one now. So here we go. The first thing we're going to calculate here is the area. There we go. This is area. Remember, area is given by some fraction multiplied by the whole area of the circle. The fraction is calculated by whatever we're doing, which is in this case, this is going to be 240 degrees because they add up to 360 degrees together. 240 plus 120 is 360, so that makes your revolution. And the fraction that we're calculating is on the inside, so we need the 240. So we take 240 divided by 360. Now that we have that fraction, we need the area of the whole circle. So if it was a whole circle, what would the entire area be completely? All right, so the whole circle would be pi r squared, right? Pi r squared, there. And the radius is 8, so it's going to be 8 squared. That'll cancel out there. 24 over 36, we might as well just put it straight on the calculator. 240 divided by 360, or 24 divided by 36, multiplied by pi times 8 squared. That'll come to 134. That'll come to 134.04 centimeters squared. Then we got perimeter. All right, then we got perimeter. Now, the perimeter of the entire circle is going to be given by adding up all of the lengths and the sides, right? So this, remember, is 8 centimeters, but that length over there is calculated by also a fraction. So what we're going to, if I have to write this out, we take the radius, which is 8 and 8. So radius plus radius plus fraction together times whole circumference now. So if we got the entire circumference, remember circumference is the perimeter of the circle. If we take that fraction of the entire circumference, add it to the 2 radii, that's what we're going to end up with. So let's go ahead and substitute. The radius is 8 centimeters. The next one is 8 centimeters. Then we're calculating the fraction on the inside. So that's going to be 240 over 360. And we've got to fit in the 2 pi r over here. So 2 pi times 8. I'm just going to squeeze it in there. And here we go. So we're going to put this on a calculator. 8 plus 8 gets me 16. And then 240 as a fraction of 360 multiplied by 2 times pi times 8 comes to 33.51 centimeters, not squared here. We're working with perimeter, so plus 16 after this, comes to 49.51. centimeters in total as the perimeter. So those are my two answers there, rounded to two decimal places, and that's where it is now. All right, today we're going to be covering a concept known as type ready when you're ready, if you've written whatever you need to. We're going to learn a concept known as transformations. How many of you know what transformations are? How many of you know what transformations are? What's a translation? What's a rotation? What's a reflection? What is all of these different types of things? All right, so no, not really. Let's have a look at a little bit of transformation so we can understand what it entails. Okay. All right, today what I want to cover is some transformations. The first thing I want to cover is a translation. Translation is, in other words, the shift. You shift something, and translation can be vertical or it can be horizontal. Horizontal, remember, is flat. Vertical goes up or down. And it's normally in the Cartesian plane that we're trying to solve or get that. Then we've got the other one, which is your reflection. When you reflect something, there's a line of reflection. Reflection can also be vertical or horizontal as well. Vertical or horizontal over a mirror line, right? So horizontal. And this is also a mirror image of something. And then you get another one which is known as rotation. And this can be 90 degrees or it can be 180 degrees. Rotation goes around a certain point, and there's also there's a center of rotation as well that exists. All right, so that's the three types of transformations that we got. There is another one also known as enlargements. There's another one that's known as enlargements. Let me see if I can put it at the bottom here. So enlargements can either be a shrink or it can be a increase or decrease by a factor. So there's a factor of increase over here, factor of increase, and also a center of enlargement. That's part of calculating. Let's go through this and see what I mean by this. If I got the Cartesian plane over here, I'm going to quickly draw up one here. So let's say that's my y-axis, and that is my x-axis. And I've got, this is my y, this is my x, and I've got a point over here that's, let's say, given by 2, 3, which means that it's 2 to the right and 3 up. Now, if I take this point A and I shift it or I translate it horizontal or vertically, I can maybe move it to this point here. Let's call it B, which is 2, -2. All right, let's say that was -2. What you can see from here, is that when I move this right down, I'm shifting this point down to B. We call B the image of A. B will be the image of A because you're technically moving the point across all the way down, right? So I shouldn't call it A. I should call it A, and you put a little dash at the top. It's called A prime, like that. And that's the image. That's the image of A. So the image of A is given by A prime. Okay. What have I done now? I've done a vertical transformation or translation. These are all transformations. Remember, these are all transformations, and that one as well. And this is called a translation. So what have I done over here? I've translated, we can call it translated or translation of a 2, 3 vertical translation, vertically downwards to my a prime, which is 2, -2, by how many units? To go from 3 to -2, I've got to go 3 down, another 2, so I go 5 down all the way by 5 units. I could also take A and I could translate it this way, which is the left hand side. I could go this way. Let's say I end up at -3 and 3, and I call this A double prime. That's another image of A. So in this case here, this is translation of A. We can also write it like this: 2, 3 to A double prime, -3, 3. And we can also state we're going horizontally left, horizontally by how many units? How many units are we going left by? Can you see? Look at the x values. I'm going from 2 to -3. And from 2 to -3. So I'm going 5 units to the left. I can write here by 5 units. All right, if you can see that at the bottom of the screen. And that's a vertical translation. Those are the type of translations. So what have I done? I've done a vertical transformation or translation and horizontal. Let's look at reflections now. Let's look at reflections and let's see what that is all about. Reflections can be also over a reflection line. So you can have the option, or you can also reflect it over the y-axis or x-axis. So this is your y, this is your x. If I've got a point over here, let's say this is 2 and 4, and I want to reflect this over the x-axis. So I want to reflect this over the x-axis. This point is going to become -4, but the 2 will remain the same. Your x value will remain the same. So from there to there, we can see this is a reflection over the x-axis, right? And this is my reflected point. So if I call this A, then this will be my image, my reflected image, which is A prime with a dash at the top. This is reflection over the x-axis. I can also reflect it over the y-axis. Can you tell me what this point would be? Can anyone guess what this point would be? And I'm going to call it double prime. If I reflected it over the y-axis, what exactly would that coordinate be? Can you see it? -2, 4. That's right, because the 2 becomes -2 and the 4 stays in place. -2, 4. Can you see the difference between a translation and a reflection? A reflection has to go to a specific point. A translation can shift past that point. It can go anywhere. It can go downwards anyway as well. But a reflection has to go exactly 2 units in this case in the opposite direction. So that ends up with -4. And this is a reflection over the x-axis, the first one. And this one that we just did now is a reflection over the y-axis. What you'll notice is when you reflect anything over the x-axis, it's the y values that change. It's supposed to be negative. That's supposed to change. Can you see that? Only the y values change when you reflect it over the x-axis, which is weird. The y values change when you reflect it over the x-axis. And the x values change when you reflect it over the y-axis. Okay, those are examples of reflections. Let's look at an example of a rotation now. You can rotate a point 90 degrees or 180 degrees. Let's suppose I've got a point that is 2 and 1. 2 to the right and 1 up. And this point over here is point A. Okay. This is my y-axis. This is my x-axis. I want to rotate this point 90 degrees clockwise. So if I start from here, if I go down here, is this 90? No. If I end up in this quadrant, that looks like 90, right? And if I take this length and I keep it the same, and I go all the way down here, you'll find that that will be 90, just about there. So I've actually moved it from there to there, 90 degrees. And that coordinate over there, which will be -1, sorry, -2, will become the coordinate A prime, because that's the image of A, 1 to the right, and -2 down. So initially I went 2 to the right and 1 up. If I go 1 to the right and 2 down, I end up making a perfect angle of 90 degrees. And this is your rotation. Now rotations can be either clockwise or they can be anti-clockwise. If you go anti-clockwise, then it would look like this. That 90 is going to go all the way. This 1 is going to become a 2, all right? And this 2 will become a 1. You'll end up swapping the numbers around. And you'll end up over here. That'll be A double prime. So if I have to do that, you can see this line, this angle over here, from here, it's going to go anti-clockwise to A double prime. All right, and that'll be perfectly 90 degrees. Drawn to scale, you'll be able to see it much more clearly, but you can see this is going 90 degrees anti-clockwise. And this one is going 90 degrees clockwise. Now what happens if I go from A dash all the way to A double dash? If I go all the way that way, what does that look like? By the way, this point, this coordinate over here, which I haven't stated it here, is -1, because that's negative A, and 2. If I go all the way from here to here, that's 180 degrees. Does it matter? Does it matter if I go clockwise or anti-clockwise when it's 180 degrees? No. Can you see? If I go clockwise, I still end up over there. If I had to go anti-clockwise, I'd still end up over there. Right? So that's anti-clockwise, and that's clockwise. But because it's 180, it doesn't matter. It will just end up over there. That will be 180 degrees. I'm just going to put 180 degrees. You can decide for yourself if you want to use clockwise or anti-clockwise. All right, the next one is your enlargement. Okay, it's supposed to be R there. Okay, enlargement. So enlargement, factor of increase, and center of enlargement. Let's draw up over here. What do I mean by that? Let's suppose you got a little rectangle over here, and you want to enlarge this figure. You want to double the size of this figure, and they tell you that the center of enlargement, which can be anywhere, center of enlargements can be anywhere around the shape. Let's choose a specific point, a random point somewhere. Let's suppose that point is over here. Let's say the center of enlargement is right over there. If you want to calculate, create a new rectangular block from scratch from here, you got to go all the way this way. So I'm going to make a dotted line here and extend it as far as I can. Then I'm going to take another dotted line and move it through this point here. That point is known as your vertex. So I'm going to go to each corner of my shape and draw a dotted line through it, like that. Now I want to double the size of this, and I want to use C as my center of enlargement. So in order to do that, I go and measure this and I say, okay, well, there we go. That's the size of it. That's the size of the bottom, more or less, right? I want to double that. I want to double that. Where would I double that? At what point would I double it? So if I look between these two lines, I've got to have two of them, right? So let's draw another one. There we go. So I got two of them. Where on these lines will they fit? So if I move this a little downwards, and I move this one a little downwards as well, over here, move that downwards, upwards over there, move this a little bit more downwards there. That is now double the size, right? So I'm going to draw a line just over there, okay? And that's going to become an enlargement of factor 2. It's called an enlargement of factor 2. So if I draw a line all the way across here, I've now doubled the size of my initial one. If I go and double this size as well, so that would be that length over there, just about there, it should fit perfectly here. Okay, so more or less it is sort of perfectly fitted there. And then I run it across till this line, and then I bring it all the way down, and then I have my enlargement, which fits in the projection. Fits in a projection with the starting point being at C. Okay, fits in the projection with the starting point being at C. Now that point C can move anyway. That point C can move wherever it wants. So I could take that point C and let's say we moved it somewhere else. Let's say I moved point C over here. Let's call it C2. I would then have to connect a projection from this point to create the enlargement, which means I'd have to start from each of these. So I'm going to use a solid line quickly. I'm going to use a solid line just to show you so it doesn't take too long. If I connect point C to all of these corners like this, all the way through there and there, we can see that that is going to be the new enlarged shape. Now, I need to double this shape. I'm going to double that, and I'm going to double that. But technically, it's going to be that size. But it's in this projection. So it doesn't go there. I can't put it there. That's wrong. That's wrong. That's wrong. That's wrong. I can't put it there. It's got to be in this projection. So I'm going to keep moving it until it fits. Until it gets to a point where it actually, there we go. Until all the corners touch the lines. There we go. Can you see every corner is touching the line? That is now, that is an enlargement that I just created there. And the center is the second C2. Supposed to be C2, right? So that's C2 over there. That's my y-axis, x-axis, and that's the projection over there. So as you can see, the center of enlargement can move around, and you just have to draw this line. The one thing you have to remember is when it comes to the factor of enlargement, when you're going from a big shape to a small shape, the factor is actually a fraction. So the fraction, if I go from red to black, the factor will be a half because I've half the size. And if I go from black to red, it will be 2 because I've doubled the size. And the same applies for the green as well. Okay, and those are the different types of transformations that you get. All right. Okay, I'm going to show you the first example, and then you can try a few of these. Now, the first question it says reflect. Reflect the shape in a given line. Okay, it says here, draw the reflection of the shape in the y-axis. Draw a reflection of the shape in the y-axis. There's your y-axis, which is vertical. A reflection would start from here. Now, you got to put in the corners, right? So you got to put the corners in. So there's the first corner. There's the second corner down, then left, down, then left again, then back up again. Click check your answer, and it's correct. It's a reflection in the y-axis. Remember, reflection in the x-axis will work on the same basis. Let's have a look at level 2. Level 2 shows a vector at the bottom. Let me tell you what a vector means. Vector means that you go 3. Now the top number is either going left or it's going right. It goes left if it's negative, it's going right if it's positive. So this one will go right. Okay, so this one's going right. This number will go up or it'll go down. It'll go up or down, right? It'll go up if it's positive, down if it's negative. Okay, so this one's going to go up. That's your translation. So that means I've got to move this shape 3 units to the right first. Then I've got to move it 4 units up. And it's going to end up somewhere over here. All right, so let's see if I can do that. If I do that, if I move the whole shape 3 units to the right, it's going to go one, this line here will move 3 units, all the way 3 units to the right. So it'll be 1, 2, 3 units to the right over here. And from there, I would then draw all the others in there. So that would mean I would put this here, this down, like that, this way. I've now translated the entire shape 3 units to the right. Can you see that? Now I'm going to move it 4 units up. If I move it 4 units up, it's going to end up, each corner is going to go up. So this point is going to go up 4 units. That point is going to go up 4 units. And then likewise, all the other points will follow suit. And there we go. I've now translated the entire shape straight from there to there, 3 units to the right and 4 units up. Let's have a look at level 3 now. Level 3, they asked me to rotate the shape about the given point. This one, they asked me to rotate it 90 degrees. So that means, remember this coordinate over here, which is at the moment, that coordinate is 2 to the right and 3 up. If I rotate this 90 degrees, we're going to swap these two values around and we're going to end up in this quadrant. So I'm going to go to 3 now on the x. The 2 is going to become a 3 and the 3 is going to become a -2. And that is how I get a rotation. I swap the numbers around and just check the signs. So this is going to be 3, -2, and you can see it's a perfect 90 degrees. You do that for every single corner of the shape. Okay, you do that for every single corner of the shape. So this corner is going to end up over there. Then you do it for the next one. The next one is going to go straight from here downwards till there. Okay, start taking shape from there. So we're going here, we're going down here till there. Then we're going to go this way. Okay, because it's going to be this line here. Remember, it's 90 degrees as well from another line, from this line here. And if I go up here, I got to go 2 here as well, because that's also 90 degrees this way. Then down this way, right this way, and down again. Okay? And you can see that is a rotation. And they'll tell you the origin. The origin is the center there. All right, the answer is correct there. At some point, the origin can change. But in this case, they're using, like for example, have a look at this one here. This one here starts at the point 1 and -1. So 1 is over here, -1 is over there. That's the center of enlargement, right? So what I want to do for this one is I want to first plot that center. I want to have a marker to say that is what they want me to use as the center of rotation, not enlargement, rotation. I'm going to take this now, take every single corner and move it 90 degrees, -90 degrees clockwise. Now, what do you think that means? That means anti-clockwise. Okay, so if they don't use the word anti-clockwise, they'll use negative. So -90 clockwise would be, take that point, go all the way this way, you'll end up over here. That point ends up over here. Go to the next point, this one over here. Take that point and go all the way 90, you'll end up over here. Then go straight through this point here, go all the way 90, you'll end up over there. So that point ends up over there, and you can see there's the shape, more or less, that corner has now moved there. And if you can follow on once you got that, it's pretty simple because you can see that line is following there. It looks like a little bit of a diamond shape. And that's your exact, from the point 1, -1, not center. From this point over here, I can now draw that shape. I'm going to draw it in 1, 2, up there, that way down, this way back. Okay, Okay, let's clear that. That's what it looks like. Let's check if it's right. The one is right. And that takes me to the last one, which is your enlargements. And don't forget the center of enlargement and combining those lines together. This one here says the center of enlargement, let's start from there, is 1, -1. Let's go ahead and plot that first. 1 to the right and -1 down is over here. Okay, so that's my center of enlargement. The center of enlargement is found within the shape. Don't forget, what do? We draw lines to each corner from the center of enlargement. From the center of enlargement, we draw lines to each corner like that. All the way through like that. Now, it says scale factor is 2, which means we've got to double the size of each length. How many blocks is that? That's 3 blocks over here. Let me just point it out in red. That's 3 blocks over there. What's 3 times 2? 6. Let's look for a point where we would get 6 blocks in between. If I drew it correctly, obviously this is not going correctly, so I have to draw it quite good, like that. And if I got to the point where I get 6 in length, let's go and create a 6 in length. There's 6 in length over there, that's the 6 in length. Just about there. And I move this. Looks like it's going to be around there somewhere, right? That looks like the center. So that's the base of it. And then what's 2 times 2? 4. So this side will be side 4. The top side is 2 times 2, also 4. Then it goes, instead of 1 down, it goes 2 down. Instead of 1 to the right, it goes 2 to the right. Instead of 1 down, it goes 2 down. And then the entire shape, you can see, has enlarged it. So let's go ahead using that center, and the arrows are also a guideline. Remember that, to give you the shape that you need. But that's the actual enlargement with that center in there. Level 1, 2, 3, 4 is ideally what I want you to try and get through. Okay, so I'm going to put the link in and you try it. Okay, give it a shot. Try your best. Do level 1, 2, 3, 4. We'll do this for 15 minutes. Practice as much as you can. Let me know when you're done with level 4. Coming through now.